Logarithm laws. So, the first thing that we're going to do is we are going to convert from exponential to logs. Now, when can we convert from an exponential to a logarithm? We can do that when we have two bases and one exponent. Okay, so if I gave you this yesterday, three equals 5 to the x plus 2. All we learned yesterday really was common base. Can we do that? No. Or calculator. We can't do that because I'm going to say algebraically. So if I have two bases, which I currently do, I have a base 3, which is just to a 1, technically, right? And a base 5, and one exponent. I can't have exponents on both, or I have to deal with this totally differently, which we will learn, but not today. If I have two bases and one exponent, I can convert it to a log. And why would we convert it to a log? Because when you convert to a log, your exponent is no longer an exponent. Okay, so this is how it works. The base of your exponent, so in this case, the base of my exponent is 5, right? It becomes the base of my log. So I get log base 5. Then what's with it in exponential will not be with it in logs. And what's with it in logs will not be with it in exponential. So right now the x plus 2 is with the 5, correct? The x plus 2 will not be with the 5 on the log. So the 3 joins it now. And the log and the 3 are the same height. And the 5 is a little lowercase subscript, and it's the base. So we get log base 5 of 3, and it always equals my exponent, x plus 2. So the reason why you would convert to a log is because you want to get that exponent down. Okay? Now I want you to solve. What else do we have to do? If I want you to solve, what else do you have to do? You have to minus the 2. So the 2 does not join the 3. The 3 is in with the log, correct? So you're not going to say log base 5 of 1. You're going to go negative 2 plus log base 5, 3 equals x. Okay? So we're going to all go over how every single calculator can do it first, and then I'm going to show you a different button. So if I give this to you like this, say I gave you log base 5 of 3. Okay? The way we could type this into our calculator if we don't have a button that looks just like that is we can go like this. Log 3 divided by log 5. So everyone do that. Log 3 divided by log 5, enter, and then subtract 2. And give me to the nearest 10. So log 3 divided by log 5, enter, minus log 2. Minus 2. I don't know why I said log 2, sorry. Yeah. You have to hit enter. If you don't hit enter, you don't close your log bracket, it's going to try and put the 2 in with it. You get negative 1.3. If you do not close the bracket behind the log, you will not get the right answer. So you're doing log 3 divided by log 5 and then subtracting 2. What's up? It just goes like this. It always just, you cut it here and put a log on the bottom. Never changes. Always the same. Cut it, put a log on the bottom. Okay? So if you have the TI-83 calculators, you have to do that method. You have no choice. You have no other choice. If you have the other calculators, ones where the exponent pop up, or the fancy colored ones, you can go math and arrow up to A. Oh, it's not. And then it gives you spaces. So you go 5, 3, minus 2. Same answer. You go math, arrow up, enter, 5, 3. Oh. So if I have 2 bases, 1 exponent, and I can't do common base, I have to convert it to a log. So example 2. Say I give you 3 times 2x plus 6 equals 24. If you go 6x plus 6 on your test, I'm going to want to rip it in half. Like I'm literally going to want to take your test and go and then maybe this way too. And then I might just like throw it out the window or fan it. Yeah, I would go over top of the atrium and just like let it rain your test, you know? Yeah, just let that test rain. So don't test that out. Just don't do it. Can these two combine? Can 3 times 2 combine and make a 6? You're like, no, they'll never do it. So many people do it. So many people. If you're like, yeah, that might be me. You come to terms with it. You're at that point in your life. Write a note and say you can't do that. Now, can I move the 3 over with the 24? Why? Yes. Neither of these have exponents, so you can divide the 3 over. I cannot currently convert this to a log because I have more than 2 bases and 1 exponent. I can only convert to a log if I have 2 bases and 1 exponent. So I have to divide the 3 over first. So we get 2 to the x plus 6 equals 8. There's 2 ways I could solve this now. Common base, or I can convert to a log. Now, when you have 2 bases, 1 exponent, you can always convert to a log. If you have 2 bases and 1 exponent, you can sometimes make common base. Okay? In this case, we could common base, but I'm going to convert it to a log. So the base of my exponent becomes the base of my log. Then you put what's not with it. So 8 isn't with it, so it's going to be now. And it equals your exponent. And then we're going to subtract 6. So we get x equals negative 6 plus log base 2 of 8, of which you do not need your calculator at all. When you have even numbers like 2 to the 8, or 2 to the what is 8, you can solve these out. So what your calculator does whenever it's doing a log is it's doing this. It's saying 2 to what exponent is this number? So it's 3. So the answer to this is 3. So that's what your calculator is doing every time. The base to what exponent is the other number. So sometimes it's a decimal, right? Then it's harder for you to do. But these ones, 2 to what exponent is 8? 3. So that's my answer. And x equals negative 3. Yeah? It is, but I often don't put it after because some people forget, especially in your type of calculator, they forget to close the bracket for the log, and then they get 8 minus 6, which is 2, and then it figures out log of 2. So that's why I always put it first so that I can't, even if I forgot my end bracket, it wouldn't matter. Yes. Enter. Minus 6. Okay. So does that make sense? Okay, then we're going to do exponential. Oh, we did exponential logarithms. We're going to do logarithms to exponential. Okay, why would we do logarithms to exponential? When we don't know what's beside the log, so for example, if I gave you this, 7 equals log x, base x of 3. If I don't know the base, if my variable's in the base, I convert to exponential. If I have 6 equals log base 2 of x plus 4, if what's beside the log has a variable, I convert to exponential. Some people will say, well, what happens if I have this? X equals log base 6 of 4. Then you guys are converting to exponential, and you're like, Mrs. Lepp, I don't know what to do now. Why are you converting? Just type that in your calculator, get an answer, move on. Okay? That is of no use. Just type that one in. So if you don't know the base, and you don't know what's beside the log, you're going to convert to exponential. So let's do solve. Number 1, 6 equals log base x of 3. I don't know the base. So if I don't know the base, I convert to exponential. So how do I convert backwards? What is the base of my log is the base of my exponent. What's with it does not stay with it, right? So this is going to be my exponent, 6. And then it's going to equal what's with it. Same thing over. So the base of my log becomes the base of my exponent. What's with it doesn't stay with it. So this is going to be its exponent, and it equals what's with it. Then I can raise this to the 1/6. And I could leave that as my answer. X equals 3 to the 1/6. Because that cancels and makes 1. But what's 1/6 also? They could give me the 6th root of 3. It's the exact same thing. Remember, the square root is a half. So the 6th root is a 6th root. 1/16. Or 1/6 is a 6th root. Or if they asked me to the nearest 10th, it'd be 1.2. I think. Number 2. What if I give you 2 log x 6 equals 4? Yeah. Because 1/6 times 6 is 1. You want an exponent of 1. The 3 is from here. I just took this log and converted it to exponential, which is the red. X to the 6 equals 3. Then I need it to be x to the 1. So I raised this side to the 1/6 because 6 times 1/6 is 1. What I do to one side, I have to do to the other side. So we did the other way around too. Your exponent becomes what it's equal to, so what it's equal to becomes your exponent. They're just backwards from each other. Yeah? Because you're solving for x. You want x. You don't want x squared or x to the 6. You want x. And x is to the, yeah. Got it. This one, if I try and convert right away, I would go x to the 4 equals 6, and then this 2 would just float. Is that a good idea? No. I need to have a 1 in front of this log. How could I get rid of that 1 in front of the log? Divide by 2. And I can do that because the 2 and the 4 both don't have exponents. So now I have log base x of 6 equals 2. And now I can convert to exponential. So the base of my log becomes the base of my exponent. What it's equal to is always the exponent. And then it equals what's beside it. Because what's friends is logs is not friends in exponential, right? So these two are together here. They won't be together here. And how do I get rid of a squared? Raise to the power of a half. Or square root it. Or the decimal is what? Where, I don't even see it. 2.4? So tiny on here. Okay. The only one we haven't went over so far is if I give you the x now beside the log, not in the base. So say I give you 6 equals log base 2 of 2x plus 1. Do I have a 1 in front of the log? Yes, I need to have a 1 in front of the log or I cannot convert this. If at any point in time you're converting it and you have a random number and you're like, I don't know where to put this number, it's not in the right form to convert. How about that? Okay? So if you're like, hey, the base of the log, because the base of the exponent is, and then you're like, there's random 2. I'm just going to ignore it. Or this is random 2. I'm just going to multiply by it. That's never a good option. Okay? That means you need to convert your log somehow to be in the form that you can use. So this one is. So base of my log becomes the base of my exponent. What it's equal to is always my exponent. And it equals what's beside it. And then I have to keep going. Minus 1. 2 to the 6 minus 1 equals 2x. And then divide by 2. X equals what? That's the 6, although it doesn't look like 63 over 2. Next thing we're doing is the 3 laws, the 3 log laws off of your formula sheet. The first one's the product law, then the quotient law, division law, and power rule. So we're going to do the product law first. Okay. So we have log 2 to the 4, log base 2 to the 4, plus log base 2 to the 8. Now people want to add them together. They want to say, okay, well that's log base 2 to the 12. When I type log 12 divided by log 2 into my calculator, I actually get 3.6. Okay? But when I do my actual math here, I can just do this in my head. 2 to the what is 4? 2. So this log base 2 of 4 turns to a 2. Plus 2 to the what is 8? 3. What's 2 plus 3? 5. Is it 3.6? No. So we cannot put these together by addition. That's not possible. The multiplication law here states that if there's ones in front of the logs, you can put them together by multiplication, but they have to also have the same base, right? So both of these have base 2. If you see bases that are the same, think they're probably trying to get me to put these together. Okay? So instead, how I put this together is I go log base 2, and if it has plus 1s in front, they get multiplied. So I get 4 times 8. So I'm going to get log base 2 of 32. 2 to the what is 32? 5. Same answer. Now some people say, well, why am I going to put them together if they're just numbers? They'll put variables in. And then you can't just solve them separately and add them. So that's the multiplication law. The quotient division law. You kind of use them both together, so I'm just doing it short form right now, is when you have subtraction and the same base. So say I have log base 2 of 4 minus log base 2 of 2. The key to this rule is the moment you have minus ones in front of your logs, you're going to have a numerator and a denominator. So whenever you have a plus 1 in front, it goes in the numerator. And whenever you have a minus 1 in front, it goes to the denominator. And they have to have the same base. If they don't have the same base, you'd be done. If one was base 2 and one was base 3, you'd be done. You just box it, you'd be done. That'd be the weirdest thing. You were given a question and you just box it. Done. No big deal. Probably not going to happen. So if they do have the same base, though, you can put them together. So we're going to write it as log base 2. The 4 has a plus 1 in front, so it's going to go in the numerator. The 2 has a minus 1 in front, so it's going to go to the denominator. So I have log base 2 of 2. What's the answer to that? 2 to the what is 2? 1. So whenever you have the base and this number beside are the same, your answer is just 1. So like log 2 to the 2, 1. And why is that? Because log 2 to the 2 is the same as this. Log 2 divided by log 2, which is 1. Okay, so what happens if I mix them up now? Simplify. Log 3a squared minus log 3a cubed plus log 3b cubed minus log 3b squared. What happens if 2 of these are base 3 and 2 of these are base 2? You could combine the base 3s, you could combine the base 2s, and put a plus sign between them. You can't put things together that don't have the same base. But the 2 that are the same, you can put together. Yes, because they all have the same base. So, our rule for putting logs together is they have to have the same base, and they have to have positive or negative ones in front. Yeah. They're right beside the log. So, you're going to have log base 3. This has a plus 1 in front. So it's going to go in the numerator, a squared. This has a minus 1 in front. So a cubed is going to go to the denominator. This has a plus 1 in front. So b cubed is going to go to the numerator. This has a minus 1 in front. So b squared is going to go to the denominator. Am I done? What could I do? On the top, I have a squared, just means a times a, right? On the bottom, I have a cubed, so that means I have a times a times a. Correct? So I can take 2 for 2. And then what happens? This is completely gone, and this one's left with an a to the 1 in the denominator. Then I can take 2 b's from this denominator and 2 b's from this numerator, and I'm left with a b in the numerator. So I'm left with log base 3 of b over a. If they want to write them side by side, they could write them at this answer as, I'm not saying they're going to, but they could, log base 3 of b times a to the what? Negative 1. And normally they'll go in alphabetical order, so they go a to the negative 1b. What happens, though, if we don't have plus or minus 1s in front? We have to get them to be plus or minus 1s in front. So our last rule is the power rule. And the power rule helps us with the product and quotient rule. So your power rule off your formula sheet is log base b m to the n equals n log b base b of m. So what are they saying with the power rule? You can take your exponent, this n, and you can drop it in front of the log, and they're the same. Now, instead of just trusting me that that's true, I'm going to show you why it's actually true. So if I gave you log base 3 of 2 to the 5, what does 2 to the 5 expanded form mean? How could you write 2 to the 5 in expanded form? They have to match. So 2 to the 5 in expanded form, what would it be? Exactly. It's going to be log base 3 of 2 times 2 times 2 times 2 times 2. Most people are really good at spotting addition and subtraction put together as multiplication division. Most people are not good at spotting, hey, I have a whole bunch of things multiplied. I can actually expand them out in addition, right? You can do the opposite rule too. You can't just always put them together by multiplication. You can take multiplication and push it out by addition. So we would get log base 3 of 2 plus 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 log base 3 of 2. How many log base 3 of 2's do I have? 5. So we just proved that this actually is equal to that. That's why we can take the number and the exponent and drop it in front. Or we can take the number in front and bring it up as the exponent. Correct? So I told you that in order to use multiplication and division law, you have to have a 1 or a negative 1 in front, correct? So if we get a number in front, we can just make it and move it up as the exponent. And then we can do our normal rules. So let's try it out. Simplify. Two log base 3 of a minus 3 log base 3 of b plus 4 log base 3 of a minus 2 log base 3 of b. So in the format I'm in right now, can I put them together? They have the same base, which is good. They're all base 3. But what I tell you has to be in front of all the logs. 1s or negative 1s. So I told you we can bring our numbers up as exponents. We're not bringing the signs up, just the coefficients. So I'm going to bring this 2 up. Cross off the 2. I'm going to bring the 3 up. Cross off the 3. I'm going to bring the 4 up. Cross off the 4. I'm going to bring the 2 up. Cross off the 2. And now I can rewrite it. Log base 3a squared minus log base 3b cubed plus log base 3a4 minus log base 3b squared. And now we're basically at the same question we were before, right? Anything with a plus 1 in front goes to the numerator. Anything with a minus 1 in front goes to the denominator. So a squared has a plus 1 in front. That goes to the numerator. Negative 1 in front. So b cubed goes to the denominator. Positive 1 in front. So a to the 4 goes to the numerator. Negative 1 in front. So b squared goes to the denominator. And when we have more than one thing in the numerator, the denominator, we multiply them. What happens when we multiply the same base together? You add the exponents. So we're going to get log base 3, a to the 6, b to the 5. So most people are really good, like I said, with if it's addition and subtraction and you have same base, you remember to put them together. But what people don't realize is to expand sometimes. So I'm just going to say expand here, But we're going to pretend that this was actually an answer you got. So you did all your math, and this was the answer you got. Log base b of b squared c. So that's the answer you got. We agree? It's not there. So my hint to you, when you have a base that's the same as the thing beside it, they're probably going to make you expand it out, and you'll see why. So what's between the b squared and the c? A multiplication. So I can separate these out with a what? Addition? We just took addition and put them together as multiplication, so we can take multiplication and separate it with addition. So we have log b to the b squared plus log bc. So why would we expand this out? Because log b to the b squared is 2. Why is that? I can take this 2 and I can drop it in front. Do we agree? So I can rewrite this as 2 times log base b of b plus log bc. And what's log base b of b? 1. Why? Because of this. So this becomes a 1. So my actual answer is 2 plus log base b of c. This is the actual answer. That's the answer you got. And like I said, you should spot this when your base and the something beside the log have the same variable or the same numbers. Because when you expand them out, it will reduce to a number. Here are 2 laws I want you to remember that everyone forgets. If I give you log b to the b to the a, what is my answer? A. Now why is that? Because I can drop the a in front and I get log base b of b. And these cancel and become a 1, and so I get a times 1, which is a. So whenever it's b to the b to the a, your answer is just a. The other one is if I give you this, log a 1. What would that equal? Now you could plug in numbers for a. You plug in 2, 3, 4, 5, 6, and see if you hopefully get the same answer every time. You will. It'd be a 0. But why is it 0? Because when I do a log, how can I do a log without my calculator? How is your calculator actually calculating the log? It's saying a to what exponent is 1? 0. Anything to the exponent 0 is 1. And this is your homework. Page 400. It's on PowerSchool in the description because it couldn't fit in the actual abbreviation. So 1 to 3, BD for 1 to 3. 8 to 9, AB. 10B, 11BC. And the conversion one, which is page 367, number 10. So that's solving exponential that you can't do by common base, but you have to do algebraically.